Hello everyone, welcome to this LeetCode video solution. In this video, I'm going to solve the LeetCode problem product of array except self. Suppose we have an integer array like this. For each element, we need to calculate the product of all the elements except this element itself. We will return the array made by the resulting product of each element, and we're going to call it the answer array. Suppose we need to calculate the self-except product for A2. We can first calculate the product of all the elements, then take the product and divide it by A2. The result of this division will be stored in the answer array at index 2. However, based on the problem description, division operation is not allowed to solve this particular problem. Besides, it won't work if A2 is 0, and we'll get a divided by 0 exception. Now that division is not an option, it seems that we need to use brute force to solve this problem. Let's take A2 for example. We could traverse the array and calculate the product of all the elements except A2. And for other elements, such as A3, we also need to do the same thing, except this time, A3 will be taken out instead of A2. If we follow this route, we'll have to traverse the array over and over again to calculate the result for each element. That will take a lot of time, approximately O(n) squared, assuming n is the length of the input array. To further simplify this procedure, let's take a closer look at the result for element A3. You'll soon notice that the product of array except A3 can be divided into two parts, left and right. The left part is a prefix product up until A3, and the right part is the suffix product up until A3. Therefore, we can use two arrays to store the prefix product and suffix product separately, then calculate the final result by multiplying these two parts. Both the prefix product and the suffix product can be obtained by traversing the input array once. That is, we can traverse the input array from left to right to calculate the prefix product, and traverse from right to left to calculate the suffix product. Now let's look at a simple example. Given an integer array, we start when traversing it forward, from left to right, to obtain the prefix product of each element. For the leftmost element 4, the prefix product of it can be considered as 1. As any number times 1 will still be itself. For the second element 5, we take the previous prefix product, which is 1, times the number at the previous index, which is 4. Then we'll get 4 as the latest prefix product. For the next element 1, we take the previous prefix product, which is 4, times the number at the previous index, which is 5. Now we get 20 as the latest prefix product. Similarly, we can calculate the prefix product for all other elements. Then, after obtaining the prefix product of all the elements, we need to traverse the integer array backward, from right to left, to obtain the suffix product. We begin at the rightmost element 6. The suffix product of it can be considered as 1 due to the similar reason. Then we move left to element 10. We take the previous suffix product, which is 1, times the number at the previous index, which is 6. Then we get 6 as the latest suffix product. Similarly, we keep traversing backward to obtain the suffix product for the rest. Now we have obtained the prefix and the suffix product of each element by traversing the input array twice. Then we will declare an answer array, traverse and multiply the prefix and the suffix product to obtain the final result, and it will store the result into the answer array. Now, let's analyze the time and the space complexity for this approach. Suppose the length of the input array nums is n. As we only need to traverse the array 3 times, the time complexity is O(n). Please note that the output array does not count as extra space during space complexity analysis. Thus, ignoring the answer array, we use left and right arrays to store prefix and suffix product. So the space complexity is also O(n). Now that we understand one approach to solve this problem, let's take a look at the follow-up question at the bottom of the problem description. It's asking us to come up with a solution that takes constant O(1) space. With the inspiration of the first approach, let's see how we can make our solution more space effective. Our goal is to make sure that the space complexity is constant. Again, please note that during space complexity analysis, the output array does not count as extra space. Now, given the same integer array, instead of using left and right array to store the prefix and the suffix product, we can take advantage of the answer array. The idea is to store the prefix and the suffix product in one single array with help of integer variables. Let's take a look at the following example. We can first traverse the input array forward and store the prefix product of each element into the answer array. Then, instead of using right array, we can traverse backward from right to left and use an integer variable right to update the suffix product of each element. Finally, store the value into the same answer array. For the rightmost element 6, the suffix product can be considered as 1, and the prefix product is 3200. The final result of element 6 is 1 times 3200, which is 3200. Then, for the next element 10, the suffix product is updated to 6. The final result is 6 times 320, which is 1920. We do the same for the rest of the elements, update the suffix product, and calculate the final result for each element. At last, we'll return the answer array. Compared to the first approach, the space complexity is optimized to constant 01, because only one integer variable right is used as extra space. As we still need to traverse the input array twice, the time complexity is still O(n), where n is the length of the input array. Now you have some idea about the algorithm. Let's begin the code walkthrough to see how we can solve this problem using these two approaches. We're going to use Java as the implementation language. We'll start with the first approach. At the beginning, we obtain the length of the input array and use the answer array to store the final result. Then we declare a left array to store the prefix product of each element and a right array to store the suffix product of each element. Then we need to traverse the input array forward from left to right to calculate the prefix product. For the leftmost element, the prefix product is 1. Then we traverse over the rest elements and calculate the prefix product by multiplying the previous prefix product and the element at the previous index. Once the prefix product are calculated, we need to traverse backward from right to left to calculate the suffix products. Similarly, the suffix product of the rightmost element is 1. Then we traverse over the rest element and calculate the suffix product by multiplying the previous suffix product and the element at the previous index. After obtaining the prefix and the suffix products, we multiply these two parts and store the result into the answer array. At last, we'll return this answer array. We traverse the input array 3 times, thus the time complexity is O(n), where n is the length of the input array. And because we use 2 extra arrays, left and right, the space complexity is also O(n). Now we're done with the first approach. Let's change the code to use the second approach. For the second approach, instead of using the prefix product array and the suffix product array, we'll take advantage of the answer array and make our solution take constant extra space. Compared to the first approach, there is no need to use the left and right array, so we delete them. Then we use the answer array to store the prefix product temporarily. Next, instead of using a right array, we can declare an integer variable right. Then we traverse backward from right to left of the input array, and each time we calculate the final result by multiplying the prefix and the suffix product, then update the suffix product. At last, return the answer array as the final result. In this way, as we don't need to use extra space for left and right array, the space complexity is optimized to O(1), which is constant. And because we still need to traverse the input array twice, the time complexity is still O(n), where n is the length of the input array. That's all for this LeetCode video solution. Thanks for watching.